Good morning, all of you. So this now the time is 9:46. So we are starting the MCA program, MCA 021, data and file structures. And myself, I am Agustinos, and my mobile number is here. And we are starting the first section. So first of all, I will introduce the structure of data and file structures, that is MCA 021 of MCA under IGNOU. So this MCA 021 data and file structure is divided into mainly 4 blocks. I think all of you get the textbook, and in this MCA 021 4 books are there, and the first book, that is block 1, that introduction to algorithms and data structure, that is the first block, and under this you can see 3 units. Every block you can see 3 units, and the first unit under block 1 is analysis of algorithm, and the unit 2, that is arrays, and unit 3, that is lists. That is the first book, and that is comes under block 1. And the second block, that is block 2, that contains stacks, queues and trees. That is the name of that block. And in that block 3 units are there, that is unit 4 stacks, unit 5 queues and unit 6 trees. And the third book, that is block 3, the name of that book is Graph Algorithms and Searching Techniques. So in this block, unit 7 advanced trees, unit 8 graphs and unit 9 searching. And the last block and the last text, that is block 4, file structure and advanced data structure. In that unit 10 sorting, and unit 11 advanced data structures, and unit 12 file structures. These are the topics that you have to study. That means I am not saying that I will cover all the blocks and units. It is not possible. I will explain why it is not possible. So the next slide. This is the semester details, the days, the dates and the time and the topics, or what is that, the portions, or yes, portions that are displayed here, and I marked the topics that I have to cover, or the days and the portions. Total here I gave 2 colors. First one, somewhat yellowish color, that represents the theory classes, and the somewhat green color that represents the practical classes. So 29, today the date is 29. So 2 sections are there with 2 hours each, total 4 hours. So it will start by 9 up to 11, then 10 minutes break, 11:10 up to 1:10. That is the first section that contains 2 classes. And on 5th 12, another theory class is there, and in 20th 12, another theory classes are there. So total 2 plus 2 plus 2, total 6 theory classes are there for us for MCA 021, and practicals are also scheduled, but I don't know how it is possible to conduct the practical sections on 6th or 13th or coming days. From the center it may be arranged. So total 11 practical classes are there, but from that some mismatches are there, because normally we are getting 10 practical classes and 7 to 8 theory classes. So maybe one practical class will be shifted to the theory class. So we may get 7 theory classes. Okay, so I explained the portions that you have to study. That is a normal MCA class semester 2. All of you are familiar with that. A semester is 5 to 6 months class in normal MCA course. The syllabus is not reduced because we are getting only 6 classes. The syllabus is not reduced. So the syllabus is a 6-month normal MCA semester, second semester class or MCA data structure class. So how is it possible to complete all the blocks and units within these 6 or 7 theory classes? That I don't know, but we will try how much portions that we can cover. But the thing is, you have to study all the blocks and units. The questions may ask from all the blocks and units for your examination. So some portions I will omit, some portions, that is some theory portions, and some practical portions that are not able to complete within this time limit. So again I am saying, normally all of you are familiar with the semester is 6 months course. So for data structure theory, in 1 week normally in a normal regular class we are getting 2 classes per week. That means 8 classes in month, 8 into 6 months, 8 into 6. That much of class may require for completing this theory. But now we are getting only 6 classes. So keep it in mind. And the first unit in block 1, that is an algorithm portion. I omitted that portion because it's a theory portion and the questions may ask for the theory portion, for the theory part of your examination. So you have to go through that, try to study that. It may contain that unit, it's contain some notations like big O notation, omega notation, theta notation, like that. The complexity of time complexity and space complexity, and the worst case, the normal case, that all covered in that unit. So if we get enough time, we will try to cover that portion also. Now we are shifting to block 1, unit 2, arrays. So I think all are from a computer background, maybe a BCA or BSc computer science or something like that. So that students, they are familiar with this unit, that is array. So I think it is easy, we can go through very fast. So data structure, here data structure, what is data structure? We are simply saying what is data structure. Data structure is a way to store and organize data in a computer. Simply we can say that. What is data structure? Data structure is a way to store and organize data in a computer so that it can be used efficiently. So data structure is the most fundamental and building block concept in computer science. Data structure, all of you are familiar with this. Data structure is the most fundamental unit and it is the building block concept in computer science. Then we are using a huge data in our day-to-day life. So to use them efficiently, we should arrange them. So we are using a huge amount of data daily. So for using it efficiently, we should arrange them. Example, words in a dictionary. the words in a dictionary, if you want to find the meaning of a word, it is very easy. We know how to find the meaning of a word in a dictionary. So because they are arranged in alphabetical order, so there is an arrangement is there. Then cash book in accounts. When we are writing cash book, then there may be some serial number, date, particulars, then the debit, credit, all these details are there in a cash book. That means here also it is in arranged manner. So here data structure, simply we can say it as DS, data structure. We can divide the data structure into two. First one is primitive data structure or basic data structure and non-primitive data structure. So all of you are familiar with this primitive or basic data structure in C. So in this primitive data structure, we know that char is there, int, float and double is there. Primitive, that is basic data structure. And in char, it uses 1 byte, int 2 bytes, float 4 bytes and double 8 bytes. So here single data value can be stored. Here we can store only single data value. In char we can store only like this A. Single data structure we can store. Then integer we can store 2 bytes of data and float 4 bytes of data we can store and double 8 bytes. So all of you are familiar with the difference between char, int, float and double. Then the non-primitive data structure, it is divided into linear data structure and non-linear data structure. So under linear data structure, the relationship is in linear form, that is sequential. In linear data structure, the relationship between the items in that data structure is linear. That means it's in sequential fashion. Examples for linear data structure is array, linked list, stack and queue. Then non-linear data structure, that is the relationship is in hierarchical order, hierarchical. So comes under trees and graphs comes under this. Here you know that parent-child relationship that you can see in this non-linear data structure. So data structure that we can divide into two, primitive and non-primitive. So this primitive data structure, the single data value can be stored and the data types that we are using in primitive data structure is char, int, float and double. This is built-in data types that is already built by C language or any other programming language. Then non-linear data structure, non-primitive data structure, linear and non-linear, and linear, the relationship is in sequential or linear form, that is array, linked list, stack and queue, and non-linear data structure relationship is in hierarchical order, that is the relationship here is a parent-child relationship and tree and graphs are comes under this data structure. So the operations of data structure, what operations that we can run in this data structure? We can insert, delete, traverse, sort, search and merge. These are the operations that we can do with this data structure. Insertion means we can insert new elements. Deletion means we can delete unwanted elements. Traversal means we can move or we can travel through this data item. Then sort means we can arrange the data in a particular order. Searching means we can find elements in this data structure. Merge means we can combine two or more this type of data structure. So these are the operations that we can do with this data structure. So the first data structure, arrays. So array is a finite order set of homogeneous elements which is stored in continuous memory locations. So array is a finite ordered set of homogeneous elements. That means when we are declaring an array, we should specify the size of the array. Normally we can't increase the size of an array. So that is finite set. It's the size is limit and it's homogeneous element. Array we can enter. For example, int a of 5 means we can enter 5 elements the type of that all the 5 elements should be an integer type. So that we call it a homogeneous element. Homogeneous elements. ഒരുപോലെയുള്ള elements and homogeneous elements, which is stored in continuous memory location. That is the other specification of arrays. It should be the array, the data stored in array, it is in continuous memory locations. So the simplest form of array is one-dimensional array. All of you are familiar with this one-dimensional array. That is the simplest form. Then declaring a single dimensional array. How we can declare a single dimensional array? The syntax is for declaring. Syntax is declaring a single dimensional array is first part. First we have to specify the data type, then the array name, then the size of the array. This is the syntax. Example, int. What is that int? Int is the data type. We can use this much of data types, char, int, float or double. So here we used int, that is the data type. Then a, that is the name of the array, a. Then 5 is the size. So this is the syntax for declaring an array, a single dimensional array or one dimensional array. Then another type of declaration, that is int b of 4 equal to 1 comma 2 comma 3 comma 4, that we put in curly brackets. That means this is the first part in b of 4 is the declaration, and this is the initialization of array. While we are declaring, we are initializing to that array. So b of 4, that means that's integer type array that contains a maximum of 4 elements, and the values we are initializing at the time of declaration. That we can do it like this. Here int, that's the data type. Then c, here we use an empty square bracket, and equal to 10 comma 20 comma 30. That means what is the, here also we are initializing along with the declaration. So 10 comma 20 comma 30 means here 3 elements are there. So the size of the array is automatically assigned to 3. So these are the 3 types of array declaration and initialization. The first part is only declaring that array. The second part, declare along with initialization. The third part also the same. There we are not specifying the size, but the number of elements will be the size of the array. If you are using 10 comma 20 comma 30 comma 40 comma 50, then how many elements are there in the initialization, that will be the size of the array. Okay. The next one, arrays and pointers. All of you, I think all of you are familiar with this pointers. So memory representation of a of 5 equal to 1 comma 2 comma 3 comma 4 comma 5. So when we are declaring and initializing an array like this, int, that means the data type, then a is the name of the array, 5 is the size of the array, and 1 and 2, 3, 4 and 5 are the initial values of that array. When we are declaring an array like this, and the memory, in the random access memory of the computer, it will assign the array like this. So in the top portion here you can see the name of the array, that is a, here that we declared. Then the values 1 comma 2 comma 3 comma 4. This is first value, this is the second value, third value, fourth value, and fifth value. And below that, here it is displayed a of 0. This is a of 1, a of 2, a of 3, and a of 4. Then what is this 1, 2, 3, and 4? All these? These are the index of that array. So when we are declaring an array of size 5, the first index starts with the value 0. That means a of 0 is the first value. Then a of 1 is the second value. A of 2 is the third value. Like that. A of n minus 1 is the last value. So here the size of the array is 5. The array index start with 0. So the last array index should be n minus 1, means the size of the array is 5. The last value should be 5 minus 1, that is equal to 4. So this is the last array index. Then memory required in bytes. When we are declaring an array, in the memory, in the random access memory of the computer will reserve some space for storing the values of that array. So memory required in bytes equal to size of data type, then size of data type into length of array. So how many bytes required for storing this array? We can calculate this. So size of data type, what is the data type here we used? That is int. The bytes is 2. So size of data type in bytes equal to 2 into what is the length of the array? The length of the array is 5. So 2 into 5 equal to 10 bytes will be reserved in the memory while we are declaring this array. So that is the memory required in bytes. Then the second type of array, or another type of array, is string array. String array is an array of characters terminated by a null character. So a string array is an array of characters, and the array terminated with a null character. This is the null character. /0 is the null character. Here we declared char nm equal to sentence. This is the string array is an array of characters. So we have to declare it in the data type char. Char nm equal to, we gave the string as sentence, initialized with the array with the word sentence. So while we are assigning a string type of array, each element part is separated. That means each character is separated and stored it in the memory. So the name of the array is nm. So here also this is the memory representation. The name is nm, and the first character s in one location, and the second character e is the another location, and the third character n is in the next location, like that. And the memory location n with a null character, that is /0. So the first element that we can represent it with nm of 0, the next one nm of 1, nm of 2, nm of 3, like that. Nm of n minus 1, n is the size of the array. So string array inserts a null character automatically. When we are declaring an array, there is no need for specifying the null character. The string array itself will assign the null character in the end of the array, that is the last element of the array. So these are the two types of array and pointers and string array, and the memory representation of arrays. Then if the array is initialized at the time of declaration, then the dimension of the array is optional. Means what? So if we are declaring an array, if we are initializing an array at the time of declaration, for example, here I am declaring an integer type array int. The name of the array is a, and I am initializing it with this much number of values, that is 25, 18, 30, then 72. If I am, this is called initializing an array at the time of declaration. So then the dimension of the array is optional. What is the dimension of array? What things that we are giving inside the square bracket, that is the dimension of the array. Dimension of array means the size of the array. So what is the size of the array now? So it will count the number of elements that we initialized. Here 1, 2, 3, 4. So the size of the array is here 4. It will automatically assign the value 4 as the size of the array. Okay, if the array is initialized at the time of declaration, then the dimension of the array is optional. If you want to give, there is no problem, you can give. So if we omit that, there is no problem. It will assign the number of elements, take the number of elements, and it will assign the size as the number of elements. Then till the array elements are not given any specific value, they contain garbage value. That means we declare another array with in data type, the name of the array is B and we declared it as 10 semicolon. So here we only declared that array, not initialized. Then what will be the value of that array? We know that if we are representing it in memory, there are 10 spaces will be there. 10 spaces will be there, and what will be the value, because we didn't initialize the values. So we are not initializing the values at the time of declaration. Then the values inside is called garbage values, means any value. It may be zeros, it may be nulls, or it may be some other values. That type of values, we are not specifying the values. That type of values we normally call it as garbage values. Any type of value, if we are printing it, then we can see some special characters or something like that. That type of value, that we call it as garbage value. So this is the 2 points. Then the next type of array, that is called the one-dimensional array, that we discussed. Then the multi-dimensional array. Multi-dimensional array are defined in the same manner as one-dimensional arrays. So if you want to declare a multi-dimensional array, that is declared in the same manner that we declare in the as we declared in one-dimensional array. So except that a separate pair of square brackets is required for each subscript. So for example, int, normally if you want to declare an array, single dimension array, we are declaring it as data type, the name of the array and the size of the array. This is the single dimension array. So if you want to declare it as a double dimension array, we should have one more bracket here. So another bracket, that is the size of the, we know that the size of the number of columns. So when we are declaring a single dimension array, for example, it's a single dimension array, it represents in memory as single row. And if we are declaring it as double dimension array, the second part is the number of columns. So this array, the name of the array is A. This array contains 3 rows and 5 columns. So when we are declaring a double dimension array, the exception with the single dimension array, a separate pair of square bracket is required like this for each subscript. Here, this is the name of the array. This is the name of the array. The name of the array is A. This is the memory representation A, and the array contains this. The name A array contains first row, that we normally call it as the row 0. This is the second row and the third row. That is the first part, number of rows, and this is the columns. This is the 0th column. This is the first column, second column, third column, and this is the 4th column. Total number of rows and total number of columns 3, total number of rows 5, total number of columns. So rows and columns are starting with 0, so we represent it with n minus 1. Here the number of rows, the value of n equal to 3, 3 minus 1, that is 2, 0 to 2, and the total number of columns is 5. So 5 minus 1, 4, so 0 to 4, that is the index of columns. Then here also bytes required equal to first index into second index into size of base type. So we can calculate the memory size for this double dimension array. How we can calculate it? First index. What is the first index? 3 is the first index into second index. 5 is the second index. 5 into size of base type. So integer, we know that the size of the base type integer is 2. So this much of bytes required for storing this double dimension array in memory. 5 into 3 into 2. So how many bytes? 5 into 2, 10 into 30, 10 into 3, 30 bytes. Okay. So this is the memory representation and declaration of double dimension array. The first part, we can find it out, the row 0 and column 0. So this is represented by column 0 and column 1, column 2, column 3 and column 4. This is row 0, row 1 and row 2. So the first element that we can represent it with, the name of the array is A. The first element that we can represent it with A of 0, 0 means 0th row, 0th column. The first part in square bracket that we say is the row number and the second part is the column number. So A of 0, 0 means row 0, column 0. Then the next element in that array is A of 0, 1 means 0th row, first column. A of 0, 2 means 0th row, second column. A of 0, 3 means 0th row, third column. And A of 0, 4 means 0th row, fourth column. Then the next row we represent it as A of 1 and again the 0th column. So A of 1, 0, the next one A of 1, 1, then A of 1, 2, A of 1, 3 and A of 1, 4. And the next row, that is A of 2 and the column is again 0. So A of 2, 0, 2, 1, 2, 2, 2, 3 and 2, 4. The next one, a pointer variable is one which stores the address of another variable. So here we are saying that another type of variable that we call it as a pointer variable. What is pointer variable? Pointer variable is one, it's a variable which stores the address of another variable. It stores the address of another variable. So that is the specification of this pointer variable. This pointer variable can store only the address. All the address should be in the data type int, right? So the pointer variable is one which stores the address of another variable. Here we declared, example, here declared x as a pointer variable. How we can identify that this is a pointer variable, x is a pointer variable, int x is a pointer variable? How we can identify that? Before that variable, we should put an asterisk symbol. If we put an asterisk symbol before a variable, that means it is a pointer variable. It's a pointer variable. It's a pointer variable. So then another variable, it's also with the same data type int, and that is an array variable a of 10. Here we used x equal to a means what? X equal to a means what? A is an array and x is a pointer variable. So x equal to a means in this x it will store what? X is, already we said that this x is a pointer variable. So in this x we can store the address of another variable. So in this x equal to a means here it will store the address of the variable a. I think all of you are familiar with what is address. For example, simply we can say this is the random access memory of the computer. All of you are familiar with RAM. And it is, we are dividing it into rows and columns like arrays, double dimension arrays. So this is one memory part. Here we can store one memory element. This is another memory part. This is another memory part. Here is another memory part. How we can identify each memory part? Each memory part can be identified by its address. It's address, memory address, and each and every memory address is unique. For example, this is 12121, for example. Then this is 15217. It is another memory address. So when we are declaring an array, when we are declaring an array, when we are declaring an array with the size of 10, here we declare an array with size of 10. So it will start storing the values from a particular address. For example, this array stored from this particular address. It may be, for example, 101 is the address. So integer type, this A is an integer type array. So each element reserves 2 bytes. So 101 and 102 is for storing the first element. Then for second element, continuous memory location will use arrays. So 103 and 104 is used for storing the second element, like that. When we are declaring an array, we should need a continuous memory locations. The bytes used for storing the array is depending upon the data type that we declared, that we already discussed. So for example, this is the first 101 is the first memory address. So x equal to a means, we know that x is a pointer variable, and in x it will store only memory addresses. It store only memory address of another variable. So in this x, it stored the first memory address, that is 101, the first memory address of the array A. That means x equal to a. I think it's clear. Then pointers and array are closely related. Now I think you understand that the pointers and arrays are closely related. So an array name without an index is a pointer to the first element in the array. An array name without an index is a pointer to the first element in the array. So here A of 10 is the array. So an array name without an index. So we are declaring is A, only A. Here we use only A. So an array name without an index is the pointer to the first element in the array. This is the pointer, or this is the first element. So pointer to the first element of the array. So an array name without an index is a pointer to the first element in the array. Example, char P of 10. What is this? This is a character array, and the size of that array is 10. So P and ampersand P of 0 are identical. Why? P and ampersand 0 are identical because an array name without an index is a pointer to the first element in that array. Ampersand P of 0 means what? Ampersand symbol represents the address of the array. Ampersand symbol represents, that we call it as address of operator. So ampersand P of 0 are identical. P and ampersand 0 are identical because the address of first element of an array is the same as the address of the array. The ampersand symbol, that we call it as address of operator. So P and ampersand P are identical because the address of the first element of an array is the same as the address of the array. Okay. Next one, here one program is there. There is hash include stdio.h because it's a C program, hash include stdio.h. Then main int 5 equal to within brace 100, 200, 300, 400 and 500. Then for I equal to 0, I less than 5, I plus plus. Then print address equal to percentage value equal to percentage n comma ampersand a of I. So just go through the program and what will be the output. Just go through. So main in 5 means we are declaring an integer type array of size 5, and along with that declaration we initialize the values 100, 200, 300, 400 and 500. Then for int I equal to 0, I less than 5, I plus plus means what? We are declaring a for loop, and in that for loop we initialize I equal to 0, I is an integer value. Then if the condition is true, that is I less than 5, that loop will continue and the value of I less than 5, and each iteration the value 5 will be increased by 1. So here print address equal to percentage value equal to percentage. Then it will print, sorry, not print but printf. So printf address equal to percentage d means what? It will print the address because we use the ampersand a of I. Ampersand a of I means address of a of I. The next one, value equal to a of I means it will print the word value equal to, then it will print the actual value that is stored in a of I. The first time I equal to 0. That means, for example, here this is the memory representation. This is the memory representation. So the values, these are the values, and these are the address, memory address. Suppose. So the first value 100 is stored in the memory address 276314. The second value 200 is stored in the memory address 276316. Why? Because we used integer data type, and this integer data type, it requires 2 bytes. So the starting memory address is 276314, and 276314 and 276315 is reserved for storing this value, the first value, that is 100. So the second element will be stored in the memory address 276316, and here it reserves 16 and 17 for storing 200, and 276318 is the base address for storing this 300, and because it is 2 bytes space is required for integer, 276318 and 19. 18 and 19 will be reserved here. And for storing 400, 276320. This is the base address 6220 and 21. Is required for storing 400. Then 500 after 21, that is 276322 and 23 for storing the value 500. So when we print it by using the printf statement, the first value address equal to, after printing the address, it will print the ampersand a, that means the address of a of 0. What is the address of a of 0? This is 0, this is 1, this is 2, this is 3, and this is 4. So the address of a of 0 means the base address of 276314. So it will print 276314. It will print only the base address. And here the value equal to, what is the value in a of I? The value in a of I means a of 0 equal to 100. So it will print 100. Then we put a /n, means what? The next iteration, the control will move to the next line. So again it will print address equal to. So it will check I equal to 0. First time the value of I equal to 0. Now the value equal to the value of I equal to 1. So 1 less than 5. The statement is true. So it will enter into the looping statement. So address of a of 1. What is the address of a of 1? Address of a of 1 equal to base address 276316. So it printed here 276316. And the value of a of I means value of a of 1 means 200. So it will print 200. So next I equal to I plus 1. Next iteration, the value of I become 2. So now this address equal to ampersand a of 2, that is 276318. The value here is 300. Next iteration, I equal to 3. Next iteration, I equal to 3. So 3 less than 5, the condition is true. Then again it will print the element here. So address is 276320, the value is 400. Again I equal to 4, the condition is 4 less than 5, condition is true. Again it will print address, that is, this is the address, base address 276322. The value here is 500. Then I equal to I plus 1, that is 5. 5 less than 5 is not less than 5. So the condition is false. It will come out of the loop. Okay. So this is the program explanation for finding the value and the address of that value stored. The next one that we call it as sparse matrix. What is sparse matrix? Those who are studying mathematics, you know what is sparse matrix. And what is sparse matrix? A matrix with a good number of zero values is called a sparse matrix. A matrix with a good number of zero values, it is called a sparse matrix. Below that you can see a sparse matrix. So these are the rows. These are the columns of the sparse matrix, and these are the rows of that sparse matrix. These are rows and these are columns. So in the zeroth row, if you are closely checking the zeroth row, here you can see only one non-zero element, that is 5. All other values are zero values. And in the first row, you can see only one non-zero value, all other values are zero values. And in row 2, you can see only one non-zero value, that is 9, all other values are zero values. And in row 3, you can see 3 non-zero values, 1, 3 and another 3. And in fourth row, you can see one non-zero value here and here another non-zero value. 2 non-zero values are there. All other values are zero values. And the fifth, here there is no non-zero values. All are zero values. And the 6, you can see only one non-zero value. That is 8. So we can say that it's a sparse matrix. What is sparse matrix? Sparse matrix is a matrix with good number of zero values. Then representation of a sparse matrix of order 7 into 6. 7 rows and 6 columns. A common way of representing non-zero elements of a sparse matrix is the 3-tuple representation. We are representing a sparse matrix by using 3-tuple form. We can represent a sparse matrix by using a 3-tuple form. So a common way of representing non-zero elements of a sparse matrix is the 3-tuple form. The first row of a sparse matrix always specifies the number of rows, number of columns, and the number of non-zero elements in the matrix that we will discuss. So the first row of a sparse matrix always specifies the number of rows. How many number of rows are there? And the second column, the first row, the second column represents the total number of columns. Then the total number of non-zero values in that matrix. So, example, this is a sparse matrix. This is the left side, you can see a sparse matrix, and the right side you can see a 3-tuple representation of that sparse matrix. So the first, this is the columns and these are rows. So this is the zeroth column, first column, second column, third column, fourth column, fifth column. So 0 to 5, total how many columns are there? 6 columns are there. 0 to 6, total how many rows are there? 7 rows are there. So in 3-tuple representation, the first row, this is the first row. This is the 3-tuple representation of a sparse matrix. The first row contains the first column contains the total number of rows in the sparse matrix. Here the total number of rows in the sparse matrix is 7. Total number of rows. And the second column, first row, second column, it represents the total number of columns. Total number of columns. So this is the total number of columns. How many columns are there in this sparse matrix? 0 to 5, that means 6 columns. And what is this 8? 8 represents the total number of non-zero elements in this sparse matrix. So just we can find 1, 2, 3, 4, 5, 6, 7 and 8 elements are there. So in a 3-tuple representation of a sparse matrix, the first row represents the total number of rows of the sparse matrix. Then the second column, the first row, second column represents the total number of columns in the sparse matrix, and the third column represents the total number of non-zero elements in that sparse matrix. So when you are referring your textbook, it may be displayed not like this. It is some errors are there. I think it's in 7, 7, 8 or something like that. So this is the actual thing. You have to correct it. You just refer your text and correct it. So the first row represents the total number of, first column represents the total number of rows in the sparse matrix. The first row, second column represents the total number of columns of the sparse matrix, and the first row, third column represents the total number of non-zero values. So that we call it as a 3-tuple representation, 3 column. In this 3-tuple representation, we should have 3 columns. Okay. The next one, how we can find, may ask for your examination also, the next line itself, after the first row, the second row itself, you have to find out the non-zero value, then the column number and the row number. So after this, these are the row, these are the rows and these are the columns. So in the zeroth row, third column, we can see a non-zero value, right? So we have to write the row number that is 0 and the column number that is 3 and the non-zero value is 5. This is the 3-tuple representation. So 0th row, third column, we can see a non-zero value. So 0, 3, that non-zero value is 5. Then again, there is no non-zero value in that row. So we are moving to the first row. Here, first row, first column, you can see a non-zero value that is 4. So first row, first column, you can see a non-zero value that is 4. And again, second row, fourth column, you can see a non-zero value that is 9. So second row, fourth column, you can see a non-zero value that is 9. Again, in the third row, next row means the third row, first column, first column, you can see a non-zero value that is 3. So third row, first column, you can see a non-zero value that is 3. Then again, the third row, in the second column, you can see a, in the third row, third column, you can see a non-zero value. That is third row, again third row, here also third row, here also third row. Here first column, here third column, you can see a non-zero value that is 2. Then again, in the fourth row, 0th column, you can see a non-zero value that is 1. So fourth row, 0th column, you can see a non-zero value that is 1. Again, same fourth row, second column, you can see a non-zero value that is 2. Then again, in the fifth column, there is no non-zero value. In the sixth row, second column. So sixth row, second column, you can see the non-zero value that is 8. So this is the 3-tuple representation. Based on this 3-tuple representation, there is one program in your textbook, program 1.1, that is in page number 27. You have to refer this page number 27 and go through this program that is written in C and just try to do it, this program. And you can also write this program in your record book. Also you can write it in the record book. Okay, so this is the sparse matrix and the representation of sparse matrix by using 3-tuple representation. I think it's clear. I already told you that some errors in your textbook, just go through the textbook and correct the errors. Okay. Then the next part is polynomials. I think you are familiar with this polynomial. We are not going to explain what is polynomial, the different forms of polynomial. We are not going to explain. This is the mathematical part. So you can refer it. What is polynomial? Just we are just touch this portion and we are going. Polynomial like 5x raised to 4 plus 2x cube plus 7x square plus 10x raised to 1. We are omitting that 1 minus 8 can be represented using arrays. So this is a polynomial. Poly means what? Poly means many. Nomial means forms. So polynomial means the meaning is many forms. Polynomial means many forms. So here this is a polynomial because 5x raised to 4 here, x raised to 3 here, x raised to 2 here, x raised to 1. If we are omitting that exponential part, that means x raised to 1 minus 8. So this is a polynomial. This polynomial can be represented by using arrays. Arithmetic operations like addition, multiplication of polynomials are common, and most often we need to write a program to implement these operations. So polynomial addition program 1.2 accepts two polynomials as input and add them. That you can refer in page number 28 of your first text, that is block 1. Just do that program in C and you can find that program. That's a working program. So you just type that program in C and run it. Next one, representation of array. The elements of an array are stored in the sequence to the extent possible. If they are being stored in sequence, then how are they sequenced? Is it that the elements are stored row wise or column wise? So the elements of an array are stored in the sequence to the extent possible. The possible extension. We can store the elements of an array in sequence. We know that. Sequence means one by one. operations on those values. Then what is ADT, abstract data type? Abstract data type is a collection of values and a set of operations on those values, that we call it as abstract data type. Then mathematically speaking, a type is a set and elements of set are values of that type. So in mathematics we can say a type that we call it as a set. I think all of you are familiar with set in mathematics, and elements of set are values of that type. Then the elements of list may be integer, the elements in the list, it may be an integer or integers, characters, real numbers, or combination of multiple data types. It's also possible. The elements of a list may be integers, characters, real numbers, or combination of multiple data types. Consider a real world problem. So we have a company and we have to store the details of employees. For example, all of you are working, most of you are working in companies. So we want to store, we have to store the details of employees. To store this, we need a data type. If we are doing program, we need a data type for storing the details of employees. So list of employees may be increased depending on the recruitment and may decrease on retirement or termination of employees. So the list of employees may be increased. It may be increased for recruitment and may be decreased. Retirement, maybe some retirements or some termination of employees. Then the operations we have to perform on this list of employees are creation of list, insertion, elements in the list, deletion, unwanted elements from the list, and traversal. We want to move, we want to travel through this list. So the list can be implemented in two ways. Array implementation, we can implement the list in two ways. Array implementation, and also we can implement it in linked list implementation. We can implement the list in two ways, array and linked list implementation. In array implementation, the entries in the list are stored next to each other within an array. So in array implementation, we already discussed that array, the data we want to store, the data are arranged in sequentially one by one. So then in array implementation, the entries in the list are stored next to each other within array. In linked list implementation uses pointers and dynamic memory allocation, that we will discuss. What is how we can use pointers in linked list implementation and what is dynamic memory allocation, that we will discuss. So array implementation, we are inserting, we are storing the data next to each other. So first we are discussing array implementation of list. In array implementation of list, we will use array to hold the entries and a separate counter to keep track of the number of positions are occurred. So in array implementation of list, we will use array. We have to use array to hold the entries and separate a counter. A separate counter. What's the use of this counter? Separate the counter to keep track of the number of positions where we want to insert. We can insert in array. We can insert continuously, sequentially. So now what is the position now and where we can insert the next element. For that we are using a counter. So a structure will be declared which consists of array and counter. So for this, in C program, all of you are familiar with the structure. So a structure will be declared which consists of arrays and a counter. So here we declare type def struct, declare a counter variable in integer data type, and for entry declare an integer type array that holds 100 elements. So by using this structure, we can declare, we can implement an array to hold the entries. So here the elements, here this is the count 1, 2, 3, 4, 5, 6 and 7. Here we already inserted, we have this much of elements. In the first position we have the value 11, the second position 22, the third position 33, 44, 55, 66 and 77. So these are the elements that we already have. So here we want to, this is the array representation. So here we want to insert one more element. So in the array implementation of list, elements are stored in continuous location that we already discussed. In array, we can store the elements in continuous memory locations. To add an element to the list at the end, we can add it without any problem. If we want to insert an element in the 8th position, we can simply add. There is no problem. But suppose if we want to insert the element at the beginning, if we want to insert an element at the beginning, or if you want to insert an element or middle of the list, in between, if you want to insert an element in this position, or if you want to insert an element in this position, so then we have to rewrite all the elements after the position. If you want to rewrite all the elements after the position where the element has to be inserted. So we have to shift nth element to n plus 1th position. So if you want to insert an element in between, for example, if you want to insert an element in the 5th position, what we want to do? We want to shift the element 77 to the 8th position and the 66 to 7th position and 55 to this position, 6th position, and here we can insert the new element. So continuous shifting is required for inserting an element in between in an array where n is the number of elements in the list. So for doing this, the count will be incremented. So you have to increment a counter when you are doing it in a program. So we will discuss how we can do it. So here, listen, we want to add 35 after element 33. So here the numbers are in sequential order. So this is before insertion, the first part, that is count is here 1, 2, 3, 4, 5, 6, 7, and the 8th position there is one blank is there. So we want to insert 35 in between 35 after 33. Here we want to insert one element. So how is it possible? How many shifts are required for that? Just try to have a look how we can insert it. Then we will discuss it. So before insertion, the elements are 11, 22, 33, 44, 55, 66 and 77. So we want to insert an element 35 after 33. So we want to shift the element in the counter position 77, counter position 7, that is 77 to the counter position 8. First we want to shift the last element, that is this element to from 7th position to 8th position. We want to shift. So here we want to shift the last element to 77. That means take a copy and paste it here. This it is not possible to errors. So in the position 7, the counter position 7, 77 is there. Also the counter position 8, 77 is there. Then the remaining elements 66 is as such, 55 is also there. Here 44, 33, 22, 11. This is the first step. After the first step, the last element in counter position 7 will move to not move, shift to the counter position 77. And it is not possible to erase what is in the 7 position. It is not possible to erase. What is possible? We can overwrite. That is only way that we can shift. So after the step 1, the value should be like this. In step 2, 77 is already there, and we want to overwrite the counter position 7 with 66. So this 77 is overwritten with the value 66. Here also the 66 is there, and here 55. Then fourth position 44. Here 33, 22, 11. And this is after the step 2. And in step 3, 77 is already there in the 8th position. 66 is already shifted to 7th position. And here we want to shift the value 55 to 6th position. 6th position, 55, 5th position counter. Also the value 55 is there. Then 44, 33, 22, 11. So this is after the shifting of step 3. Then in step 4, 77 is there, 66 is there, 55 is shifted here, and in the 5th position we shifted the value 44, and the 4th position is also 44 is there. We can't remove that, we can only overwrite 33, 22, 11. So after step 4, the values in counter positions 1, 11, second position 22, then 33, 4th and 5th position 44, 44, and 55, 66, 77. Then here we can insert the new element. So the last element, that is 77, this is 66, then 55, 44, and we want to insert the element to add 35 after 33. So here we can, 44 and 44 is there. This position, the 44 is replaced with the value 35, and 33 is there, 22, 11. So these are the steps for inserting a single element in between other elements. So before insertion, you can see that 11, 22, 33, 44, 55, 66, and 77. We want to insert an element 35 after 33. That is the task. So in step 1, we can shift the last element 77 in the position, the counter position 8. So already the data in counter position 7 is there, that is 77, and also we are copying and shifting it to 77. While we are shifting, we can't remove the element. Only we can do is we can overwrite the element. So like this we can overwrite the elements. In the step 4, more 44 is there. Okay, I think it's clear to you, and some programs are there in your textbook. Insertion, some programs are there, so you have to go through that program and do that program. Complete program is there, you just type it and run it. So that is the insertion. Then next one, deletion. To delete an element in the list at the end, we can delete it without any problem. If you want to delete an element from the end of the list, simply we can delete. But if you want to delete the element at the beginning or middle of the list, then we have to rewrite all the elements after the position where the element that has to be deleted. If you want to delete one element, for example, if you want to delete this element 44, then what we want to do? We have to shift this 55 to this position, then the 66 to this position, and the 77 to this position. Then only we will get an extra space in the end. So it is not possible to rub this like this. If you want to rub this, it is possible. When we are writing it in a board, it is possible to rub, but in memory there it is not possible to rub an element from one memory location. We can do only overwrite the element. That is only. So if you want to delete the element in counter position 4, then you have to shift the element 5 to 4, 6 to 5 and 7 to 6 and overwrite the position 7, counter position 7 with the new element, or we can simply ignore it. So to delete an element in the list at the end, we can delete it without any problem. But if we want to delete the element at the beginning, or middle of the list, then we have to rewrite all the element after the position where the element that has to be deleted. So we have to shift r plus 1 the element to r position, where r is the position of deleted element in the list. The r plus 2th element to r plus 1 the position, and this will continue until the nth element to n minus 1 the position, where n is the number of elements in the list. So while we are inserting, that we saw that this shifting and deletion also we should have this much of steps that we have to do. So we are discussing how we can delete an element. So we want to delete the element 44 from the list. For example, if we want to delete the element 44 from the list, how we can delete the element 44 from the list? So before deletion, in counter position 1, the element is 11, second 22, 33, 44, 55, 66 and 77. So when we are deleting the element in count 4, before that all elements are same, 11, 22, 33, and here we want to delete. So we want to shift the element from the 5th counter position to 4th counter position, that is 55 here. Here also 55 is there, then 66, 77. This is the, after the first step, the elements will be like this. Then the second step. So left position of the deleted element, it is same, 11, 22, 33, then 55, and the 5th counter position 55 will be replaced with 66 and 77 is there. So this is after step 2. And the last position, that is 11, 22, 33, 55, 66, here 77 will be shifted here, and here also if you want to write 77 here, it's all, you can write it, or you can replace it with another number. So this is the last step, step 3. After step 3 it will be like this, 11, 22, 33, 55, 67, 77. Here in the end we will get one blank space. You can insert a new element over here. So if you want to write here 77 in the 7th position, it's okay. Then when we insert a new element, it will be replaced with the with that element. The 77 in the 7th counter position will be replaced with the new element. Okay, so these are the array implementation of list, insertion and deletion. So I think it is enough for today, and we will discuss the remaining portion, just array implementation of list, abstract data type that we already discussed. It's a theory portion, array implementation of list and insertion by using array, then deletion by using array. So programs are there, each and every action, insertion, deletion, by array implementation, by linked list implementation, there are programs are there, and all the programs are in your text. You have to go through that text and you have to do it. That program you have to do it, and also you want to write it in your record book. So I think that's all today, and we can meet on next day. I think it's on 5th. And if you have any doubt or something, share with me. You can share it right now. Anything is there? Any clarification, or if you can call in between? My number is there. Anything is there for share with me? Otherwise, you can leave. Thank you. Thank you very much.